Hi, in this video we'll see how to use the yield from statement with generators. If you haven't watched my previous generator videos, it's definitely recommended to do it before you go on with this video. And now first, let's have a look at a typical generator. Def car generator for car in hello, yield car. Fine. Let's create an iterator. It equals car generator. And now I can call the next function. Next it H, next it E, next it L, and so on. Now here we have a string, hello, which is an iterable. Now if we have an iterable, we can use the yield from statement instead. So inside the body of a generator function, we can use the yield from statement. It must be followed by an expression that evaluates to an iterable, from which an iterator will be returned. So now let's rewrite our car generator with a yield from statement. So def car generator yield from hello. And now we have it equals car generator, next it H, next it E, next it L, and so on. So these two generators generate the same output. In the yield from version, the expression is hello, which evaluates to an iterable. The expression following yield from may be a generator too. Let's define two generators. First parts, which will yield the first 5 characters in each of these words, and doubles, which will yield the number multiplied by 2. Now let's use the two generators in another generator. So first let's use them in a generator without the yield from statement. So def words and numbers for word in first parts yield word. For number in doubles yield number. Okay, let's try it out. So as you can see, we first get the first part of the words and then doubled numbers. And now let's use them as expressions in the yield from statement. Def words and numbers again. Yield from first parts yield from doubles. Let's try it out. And now let's use our generators in a bit different way. So words from first parts equals a list comprehension item for item in first parts. So in this generator, words from first parts, and this is what we get. It's a list because we used a list comprehension here. And now numbers from doubles. Numbers from doubles equals a list comprehension again, item for item in doubles. Now let's print them out. Numbers from doubles. And what we get is a list, because also here we used a list comprehension with the following numbers 0, 2, 4, 6, and 8. As we saw before, the generators words and numbers and words and numbers again return the same elements. We're using list comprehensions to make lists of those elements. So items from words and numbers equals a list comprehension item for item in words and numbers. Let's print it out. Items from words and numbers, and this is the list. And now items from words and numbers again equals a list comprehension item for item in words and numbers again. Let's print it out. Items from words and numbers again. And we get the same list. The output we just saw visualizes that if we use a generator as the expression after yield from, it works exactly the same as if we had the subgenerator's code in this place. If there is a return statement in the subgenerator that returns a value, the returned value will become the value of the yield from expression. Here's an example. Def subgenerator yield 1, yield 2, return hi there. Now def generator n equals yield from subgenerator print n. And now for x in generator print x. And this is what we get. 1, 2, hi there. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.